Alright, welcome back to this training session. I know you've been having classes, so I do not want to take you into another lesson. But we are just doing a training because we are raising an environment club. But it will be worthless to raise an environment club that does not know why it is existing. Okay? That is why we decided to take you through this course of this little training on climate change. Okay? For those who have been following our trainings, for those who have been following what we have been doing, we began by defining climate change. And when I came here today, the first thing I let you know is that today has been pretty hot. I've been moving out there, I do other things out there. And today, I've never felt such heat in a long time, especially within people. Alright? So that still tells us that the climate has changed and the air is warming up day and night. And so we really need to understand what's happening. So we say climate change, this is the a shift. Is a shift or is a flip side or a change in the average environmental or average climatic conditions of a place which have been recorded or observed over a long period of time. So we began by asking ourselves what are the basic causes of climate change. And we looked at three most important ones. Which one? Yes? Yes? The first cause we say is desertification. Desertification. Yes? Any other? Deforestation. Thank you. And another one?
Air pollution.
All of us? Now, when we'll be looking at the effects of climate change, you will realize that we will also talk about desertification again. Alright? So there is a way desertification is a cause and an effect of climate change. So today we look at global warming as the third cause. We had defined global warming, and what had we said is global warming? You guys need to catch up. Very fast. Global warming. From the words globe and warming. So what did we say? Sorry, read loud.
Is an increase in the average temperature of the earth.
An increase in the average temperature of the earth. Now, another thing that we need to have said is that over time, you know, a place usually was known with a certain temperature average or a daily or monthly temperature. But it has been realized that in the recent date today, the temperatures of some places have risen to 1.5 degrees Celsius. And averagely, there is a very high increase. So we had also asked ourselves, what are the causes of global warming? What are some of the causes of global warming? Who can tell us?
Pollution of the air.
Talk about air pollution. And when we talk about air pollution, what exactly do we mean? Air pollution. Okay, those are what pollutes air. But now I was just asking, what is air pollution? I know I had not given you in the notes we wrote last time. I know I had not told us what air pollution is, but I expected that we should know. What is air pollution? Pollution of the air, so it's the same thing. You have not tried. Yeah, but that's a good attempt. So, it is the emission. So she's talking about the emission of greenhouse gases into the air, and that is true. So the point is, global warming, air pollution is introduction of air pollutants. Say air pollutants.
Air pollutants.
So air pollutants, and in this case we said the key air pollutants are greenhouse. We call them greenhouse gases. Alright?
Yes.
And we gave examples of some of the greenhouse gases. What did we say? One? Everybody? Carbon dioxide, yes.
Methane.
And
Chlorine.
fluorine. So we call them chlorofluorocarbons, CFCs. We call them chlorofluorocarbons. Fluorofluorocarbons.
Chlorine.
So talk about methane. Methane.
Chlorine.
Any other? Chlorine is under chlorofluoro. So under here we have chlorine, fluorine,
Carbon.
carbon, especially carbon particles. But this one is carbon 4 oxide, which contains particles of carbon and oxygen combined. In Form 2, you will learn about bonding, structure and bonding in chemistry. So you get to understand that a bit better. Now, there are two things that we have not mentioned that are also causes of global warming. So, number 1 was greenhouse, number 2 was smoke, and number 3 is dust. Dust particles. So we had mentioned greenhouse gases, but we needed to add smoke and dust particles. So someone here is wondering how are all these are related to global warming. And now that is exactly what we want to do. And I say we are going to demonstrate by use of some simple diagrams. Say simple diagrams.
Simple diagrams.
Simple diagrams. So I'm sure this one you have already written because you have written these ones. So I believe you just added smoke and dust particles. So the question we want to answer today is, how does global warming happen? That is the question we want to answer. How does global warming happen? How does global warming happen? That is the question. And I'm sure once we are done with that, we will be done for the training today. We'll go home. Then when I come again, now we will have finished looking at the causes. We will now, in the next session, we'll begin looking at the effects of climate change. And then after effects of climate change, the third and most important subheading would be, how do we control, how do we mitigate, or how do we reduce, or how do we adapt to climate change? So our training has been broken into 3. Number 1, it is causes of climate change. Number 2, effects of climate change. And number 3, how to control climate change. So the question we are answering today, how does global warming happen? How does it happen? So I want you to go with me step by step as we describe this. Now, all of us, we know what causes heat on earth. Every morning when you wake up and you're feeling cold, but after some time you'll feel it's becoming warm, and now you'll remove your sweaters and you'll feel okay. What happens? Sorry? What causes, what brings about the warmth that we're feeling on a daily basis?
Choker.
What is it doing? I mean, what are we doing? It's the sun. Okay? So, the earth gets heated up by solar energy. Say solar energy.
Solar energy. Solar energy.
Now, I'm going to describe to you what it means. Solar energy are those rays. Okay. Solar energy is the energy from the sun. Okay? It comes in form of heat. Sawa sawa. Now, how does that heat get to the earth? It gets to the earth through what we call solar radiation. Say solar radiation. Solar radiation. So, solar energy gets to the surface of the earth through solar radiation. Does it make sense? The energy from the sun gets to the earth through what we call solar radiation. Say solar radiation. Solar radiation. Solar radiation. And solar radiation comes in form of the rays. We know sun rays, right? The sun's rays. The sun's rays. So those rays are what we are referring to as solar radiation. What do? They bring about the solar energy. They bring about solar energy which now heats the earth. But what happens? Does the earth just get heated? No, it does not just get heated. What does that mean? It means that when the rays come, they do not begin hitting the air. The rays must get to the surface of the earth. Say the rays must get to the to the surface of the earth? The rays must get to the surface of the earth. Everybody?
The rays must get to the surface of the earth.
Now, what do we mean by the surface of the earth? The surface of the earth means it must get to the ground. Sawa sawa. Like the air does not get heated. The rays pass through the air to the ground. Now, and what does that ground mean? The ground could be the roof, could be the field, the grass, top of the trees, anywhere. The ground. Sawa sawa. That's what we're talking about as the surface of the earth. Now, what happens to the surface of the earth? The surface of the earth, just like any other object, they will now begin to absorb the heat. Ukichukua a metal and then you begin heating, does it become hot immediately? It will absorb the heat first. Once it absorbs the heat, then it will begin to transmit the heat through the object. Is that clear? So that is the same thing that is happening. So we say that we are not going to demonstrate. We are having the sun here. Okay? Now, and we are having the ground here. The ground is usually not very flat. So we want to call this the ground. Let's just call it ground. Okay? And we are saying this sun will release its energy, and that energy must get to what? Must get to the ground in form of solar radiation. And those radiations are the common sun's rays. So, this we call it solar radiation. Are we together? Because our?
Yes.
Now, this sun releases its energy to the ground. We call it Earth's surface. In brackets. It comes, and what should happen? We are saying this ground must absorb the heat. Are we together?
Yeah.
Now, when the ground has absorbed the heat, it will begin emitting it back. So once the ground receives the heat, it begins to hit the air that is in contact with it. Tunaelewana? Acha nirudishe kidogo. The ground is now hot. What will happen when the ground is hot? The air is always in contact with the ground. Sindio? So the air that is on the ground begins to be heated. And now when the air on the ground begins to be heated, we know by physics is that when the particles are heated, they become lighter, so they begin to rise up. Is that true?
Yes.
So when they begin to rise, they give way for other particles that are called to be heated. And therefore, the heat begins to hit the air. So it begins to get heated upwards. But one thing that we must know, how does that air get heated? It gets heated by the earth. When the earth absorbs heat, it becomes hot, and now it begins to release the heat back. Now, the sun gave us energy in form of solar radiation. When the earth absorbs the heat, it begins to emit it back. It begins to send it back. It begins to send it back. Now, it sends it back in a form of energy called terrestrial radiation. Call it terrestrial radiation. Sorry, I didn't hear you. Sema terrestrial? Aya, sisi wote tuseme ni ashaidike terrestrial. Not tele. Terrestrial. I understand why I am so I'm not going to judge it. I hope we are making sense. Now, the energy from the sun gets to the ground, it hits the ground. When the ground gets heated, it begins to emit heat back. When it begins emitting the heat back, that heat comes in form of terrestrial radiation. This terrestrial radiation is now what starts to heat up the air that is on the ground upwards. And we know that heat transfer in fluids. Heat transfer in fluids is called convection. You remember convectional currents? You remember convectional currents? Heat transfer in matter. Number one, it is through radiation, and we have talked about solar radiation. The energy from the sun travels through a vacuum to get to the ground. Sawa sawa. That is solar radiation, and that is the energy transfer called radiation. Now the earth absorbs the heat and distributes it back in form of terrestrial radiation. But that terrestrial radiation now begins to heat up the air on the ground or in the form of conventional current. Say conventional. I hope you guys understand what I'm talking about.
Yeah.
I just hope you understand what I'm talking about. We're saying terrestrial radiation. Terrestrial radiation. Now heat up the air on the ground. Heats up the air on what? Heats up the air on the ground in form of convectional currents. So it's the convectional currents that will begin heating up the air, because now this air is a fluid, and therefore it's convectional currents. When the air gets heated, it rises. The cold one drops. It gets heated, it rises. And now it forms cycles which we are calling convectional currents. Are we together? That's terrestrial radiation. Now, terrestrial radiation will hit, and now it's going to get up into the space, and it's going to get what we call this? Clouds. Are you together? Yeah. I call them clouds. Or my name looks like an N. One asifiwe.
Amen.
Now, these clouds, many clouds or most clouds are made of moisture. Are we together? Moisture. Hizo zenye zinaleta mvua. But we have some clouds that are formed by smoke. We have some clouds that are formed by smoke. And we have some clouds that are formed by smoke. And we have some clouds that are formed by water. We have some clouds that are formed by. Are we together? Now, I was about to say this. Normally, when the clouds are made of moisture, the excess heat will escape into space. Say escape into space. Not escape. I said escape. It will escape into space. So naturally, nature dictates, that is how Earth has been doing it for all those years, that the excess terrestrial radiation will be lost into space. So is it a bomb? So it will escape into space. Now I want to take you back where we started, up to where we are.
Yes.
Because this is very important. If you don't understand this, I will not have helped you. The sun releases its energy, which we call solar energy, onto the Earth's surface through solar radiation. Are we together? When the solar radiation reaches the Earth's surface, the Earth will begin to absorb the heat. When it absorbs the heat, it will begin to emit it back. To emit is to release it back. Wakati heat ni nyingi, what happens? Hata wewe when you are hot, don't misinterpret me. Don't misinterpret me. When you are hot, mtu akipita penye uko, they will feel the heat. Isn't that true? It is obvious. The body will release the heat when you become too hot. And now I'm telling you guys,
Once not hot.
Okay? Yeah, I'm just talking about the excessive heat from the body being released, because human beings are warm, are warm beings.
Once not hot.
We can cold-blooded for us in our warm-blooded. So when the body is hot enough, it cannot contain the heat, it will begin releasing. And that's what the people
Once not hot.
Alright? Even when you have fever. Okay, now let me give a good example of fever so that you don't misinterpret me further. When you have fever, you are extremely hot. And by then, fever is very dangerous to any living thing.
Right?
Fever is very dangerous. Actually, if there is anything that can kill you very fast, it's fever. Because fever will begin heating up the body cells. And when the body cells begin to die, my friend, you are as good as dead. And that's why it's so dangerous. If you feel fever, please ensure you take medication very fast. Sawa sawa. Now, having used that example, we said even the earth, when it has enough heat from the sun, it will begin to release it. And when it releases it into the atmosphere, and it begins to heat up the atmosphere. The atmosphere is the air. Sawa sawa. And we know that the air is made up of various gases, oxygen, carbon dioxide, rare gases, and nitrogen, okay? Now, naturally, after the atmosphere has been heated enough, the excess heat is supposed to be lost into the outer space. Why am I saying this? Because all of you have studied Introduction to Geography for 1.
No.
You have looked at geography and you talked about atmosphere. And we have layers of the atmosphere. The first layer is called the troposphere. We have the stratosphere, mesosphere, and the thermosphere. Now, after all those layers have been heated by this terrestrial radiation, the excess heat traverses or it gets beyond the we call them exosphere, like the outer layer of the atmosphere, and then it begins lost into the outer space. Now, this is where now global warming process begins. From here, we do not have clouds. The excess heat is lost into the space. Sawa sawa.
Yes.
So, hapa juu we say excess heat lost into outer space. Excess heat is lost into outer space. This is now in a normal setting. Before we introduce all these into the atmosphere. So, normally it should be that the atmosphere